Hello friends, the topic for today is standard representation for logic functions. Logic functions are expressed in terms of logic variables. The values assumed by the logic functions and the logic variables are in the binary form. Any arbitrary logic function can be expressed in the forms sum of products SOP and product of sum POS. In today's video, you will learn the standard representation for logic functions in these forms. Let us start. Welcome to our channel Engineering and Technology for You. If you have not subscribed to our channel, kindly subscribe to the channel and press the bell icon so that you will get notifications for future videos on this topic. Standard representation for logic functions. This is the topic for today. Let us start with the introduction. The Boolean expressions are expressed in terms of logic variables. So we have the Boolean expressions which we are representing in terms of logic variables. So binary variable may appear in its normal form, that is for example a, or in its complement form a dash or a bar. So it will be a single variable and its values will be either 0 or 1, that is binary. Now consider two binary variables a and b combined with AND operation. Since each variable may appear in either form, there are four possible combinations: a dash b dash, a dash b, a b dash and ab. These are the four possible combinations for the AND operation. Now each of these four AND terms is a distinct combination and is called as the MINTERM or a standard product. So MINTERMS and standard product, it is same. Then in the similar manner, a n variable can be combined to form 2 raised to n MINTERMs. So n variable means here we can have 2 variable, 3 variable, 4 variables. So the value of n will be 2, 3, 4 like that. And it will be combined to form 2 raised to n. So if it is 2 variable, it will form 4 MINTERMs. If it is 3 variable, n value of n is 3, then it will form 2 raised to 3, that is 8 MINTERMs. If it is 4, then 2 raised to 4, that is 16 MINTERMs. So in this way, the n variable will form 2 raised to n MINTERMs. Then the 2 raised to n different MINTERMs may be determined by a method similar to one shown in table 1. In table 1, we are going to show the method how to determine these MINTERMs. So the binary representation from 0 to 2 raised to n minus 1 are listed under the n variables. So each MINTERM is obtained from an AND term of the n variables, with each variable being primed if the corresponding bit of binary number is 0 and unprimed if its bit is 1. So this we have to understand. Here if we are going to take 3 variables, so 2 raised to n minus 1, that will be 7. So 8 minus 1, that is 7. And so, and whatever MINTERM it will be obtained with each variable being prime if its corresponding bit is 0 and it's unprimed if it is 1. So in the similar manner, n variables forming OR terms with each variable being prime or unprime, provide 2 raised to n possible combinations called Maxterms. So if it is forming AND terms, that is we call it as the MINTERMS, and if it is forming the OR terms, we call it as the Maxterms, or it is called as the standard sums. You can see this table. Here we have the variables, three variables A, B, C, and then we have the MINTERMS. These are the MINTERMS, and they are designated with letter small letter m and the suffix which is decimal equivalent of this 000, so that represents 0. Similarly, this 7, so it will be 111, that is binary 7 in decimal. So similarly, we have the Maxterms which are placed here, and they are designated with capital M and the subscript 0, 1, 2, 3 up to 7. So if you take the first term, it is 0, 0, 0. So now here these all A, B, C, they are 0. So that's why we take the minterm as A dash, B dash, C dash and represent it as M0. Then 0, 0, 1. So it will be A dash, B dash and C. Now this is 1, so it will be kept as it is, and it will be if it is 0, we will take it as the dash. Then similarly, next term 0, 1, 0. So it will be A dash, B, C dash. The next term A dash, B, C, because these are both are 1, 1. The next term is A, B dash, C dash. Then this is A, B dash, C. Then this is A, B, C dash. And last term 1, 1, 1, that will be ABC. So they are designated from M0 to M7. Similarly, Maxterms. Now here we are taken this as the AND terms. So they are in the product form. Whereas the Maxterms, they will be in the form of sum or operation. So in this case, we take 0, 0, 0. So for this we take opposite. So A plus B plus C, because all the terms are 0, and that will be designated as M0. Then here this is 1, so we will take it as C dash. Then for the next term M2, we have 0, 1, 0. So this will be taken as A, B dash and C. The next A, B dash, C dash. Then this will be A dash, B C, B plus C. Then this will be taken as A dash, B plus C dash. Then A dash plus B dash plus C. Then last term will be A dash plus B dash plus C dash. That will be M7. So in this way we form the minterms and the maxterm for the three variables, and we can same way do it for the two variables or four variables. N variables we can do. So for four variables, we'll have to add one more variable d here, and then start from 0, 0, 0, 0, and then d will become 1, like that. So in this way, we can form the minterms and the maxterms. Then Boolean function may be expressed algebraically from a given truth table by forming a minterm for each combination of variables that produce 1 in the function, and then taking the OR of all those terms. So here you see we have this truth table for the function f1 and f2. So for 0, 0, 0, this is giving 0, this is also giving 0. For 0, 0, 1, this is giving 1, whereas this is giving 0. Then this is giving 1 for 1 0 0 and 1 1 1. Similarly, function f2, it is giving 1 for 0 1 1, then 1 0 1, 1 1 0 and 1 1 1. So when we are expressing the function f1 in the table, we can determine it by expressing the combinations of, now here this 1, it is 1 here, so its combination will be 0 0 1, and second 1 is here, so the combination is 1 0 0. You can see the this particular row 1 0 0. Then here last one is here, so that is 1 1 1. So when we take these combinations, we take the minterms. So the first minterm will be a dash b dash c. The second minterm will be a b dash c dash, and the third will be a b c. So that is what we have seen in the last table. So in this way we have to express the combinations of ones and zeros in the form of the variables a b c, like that. So once we express that, we can write the equation. Let us see how we can write. Now since each of these midterms result in f1 is equal to 1, so f1 we can represent it as a dash b dash c plus a b dash c dash plus abc. So that is the sum of the midterms m1, m2 and m7. So this is for the midterms. And if you want to, similarly we can go for the second f2. So f2 is expressed as, if you want you can just, so here it is 1 here, so 0 1 1 3, then for 5 6 and 7, so we can represent it in this way. So 0 1 1, then 1 0 1, 1 1 0, 1 1 1, like this. So it will be m3 plus m5 plus m6 plus m7. So in this way, any Boolean function can be expressed as sum of the minterms. Then let us go to the complement of Boolean function. So let us consider complement of a Boolean function. So we can read it from the truth table by forming each combination that produces 0 in the function and ORing those terms. So same table we have drawn it again here, function f1 and f2. Now only here, instead of considering 1, we are considering 0. So this will get 0 0 0. So that is nothing but a dash b dash c dash, plus second is here, so it will be a dash b c dash. Then next it is here a dash bc. Now here we are considering all the zeros. So first we have taken a dash b dash c dash, then here this is nothing but a dash b c dash, then this is again a plus b dash c dash, and then we have to take this one 1 1 0 last, that is a b c dash. So all the zero terms we have to take now. So if we complement this, now we already De Morgan's theorem says that product of, if you take the complement of products will get the sum of the complements. So this will change to a plus b plus c, then this will be a plus b dash plus c, then this will change to a plus b dash plus c dash, this will change to a dash plus b plus c dash, and this will change to a dash plus b dash plus c. So we are going to get, if you take these terms individually, so this is nothing but the max term m0, then this combination is nothing but max term m2, then this is nothing but max term m3, this is nothing but max term m5, and this is nothing but max term m6. So we are getting the product of the max terms m0, m2, m3, m5, and m6. Similarly, if you take the function f2, so here this 0, so it will be a plus b plus c, then this 0, it will be a plus b plus c dash, then here this 0, it will be a plus b dash plus c, and then for this 0, it will be a dash plus bc. So it will be the terms m0, m1, m2, and m4. So that is nothing but the complement of Boolean function. Then let us go further. Now these examples demonstrate a second important property of Boolean algebra. So any Boolean function can be expressed as a product of max terms. So firstly, we have seen any Boolean function can be expressed as the sum of min terms, and here the second property says that any Boolean function can be expressed as product of max terms. So the procedure for obtaining the product of max terms directly from the truth table, we have the form a max term for each combination of the variables that produce 0 in the function, and then form the AND of all those max terms. So here we have to consider the variables which produce 0 in the function and not 1. In case of min terms it will be 1, in case of max term we have to consider it as 0. Then Boolean functions expressed as sum of min terms or product of max terms are said to be in canonical form. So when we express them as sum of the min terms or product of max terms, we call it as the canonical form. We'll see the canonical form again. So here sum of the product form. So when two or more product terms are summed by Boolean addition, the resulting expression is the sum of products, or we call it as the SOP, sum of product. The hardware implementation requires odd output of the two or more AND gates. So here the product term is produced from the AND gate and the SOP expression is obtained from the OR gate. So we'll need AND gates as well as the OR gate in the hardware. Then we have two expressions, SOP expressions, non-standard and standard. The non-standard means what? The SOP expression in which some of the product terms do not contain all variables. For example, if you are having 4 variables and the product terms, they are having only 2 or 3 variables, that means the fourth variable is not present. So that time we call it as the non-standard expression. And a standard SOP expression is one in which all the variables in the domain appear in each product term in the expression. So when we are having different terms and each product term has all the variables, then we call it as the standard SOP expression. We'll see how What are the steps for conversion of non-standard to standard? Say steps to convert non-standard SOP to standard SOP form. So there are two steps here. Multiply each non-standard SOP by x plus x dash or x bar, where x is missing variable, and expand the expression. So repeat the above step until all resulting product terms contain all the variables in either complemented or normal form. So these are the two steps. Let us understand how we can use them. So let us take the example. So here we have the function f is equal to a b bar c plus a bar b bar plus a b c bar d. Now here this is the function. It is a 4 variable Boolean expression. So a b c d, these are the 4 variables. Now here if you look at the first term a b bar c, here the term d is missing. Then second term, that is a bar b bar. Now here in this case the terms c and d both are missing, and the third a b c bar d, here no term is missing. So the first two terms will have to multiply by x plus x dash or x bar, where x is the missing variable. And first term, the missing variable is d. So we multiply the first term a b bar c by d plus d bar. So we'll get a b bar cd plus a b bar c d bar. So individually we are multiplying it. Then second term is a bar b bar. So here both c and d are missing. So first we'll multiply, here we'll have to multiply it by both the terms, c plus c bar and d plus d bar. So first we multiply with this three terms. So a bar b bar c, then a bar b bar, here we'll have to multiply by d plus d bar. So finally we are going to get this a bar b bar cd. So c d, these terms are coming. Then a bar b bar c d bar, second term will come. Then a bar b bar c bar and d, and a bar b bar c bar d bar, all bars. So these are the terms we are getting. So first term we have these two terms, then for second term we have these four terms, and this one term. So there are total 7 terms. So we write them here. So first we take the first term a b bar cd plus a b bar c d bar, this one. Then a bar b bar cd, then a bar b bar c d bar, then a bar b bar c bar and d, then a bar b bar c bar d bar, and last is this term, which is the part a b c bar d. So all the 7 terms are written, and now we take the binary equivalent of this. So this is a, so we take it as 1, b bar we represent it with 0, then c 1, d 1. So this will be 1 0 1 1. So that represents the M11, minterm 11. Then a bar b bar c d bar. So 1 0 1 0. So that is representing M10. Then a bar b bar c d, that is 0 0 1 1. So that is M3. It will represent M3. Then a bar b bar c and d bar, that will represent M2. Then a bar b bar, then c bar and d, so it will be representing M1. And these all are bars, So it will represent M0, and this is A, B, C bar and D. So 1 1 0 1, that will represent D. So now all these terms, whatever we are getting, we can express in the algebraic form. So F is equal to summation of M 0, 1, 2, 3, 10, 11 and 13. So this representation we call it as the canonical form of the SOP, sum of products. So this is how we can convert the non-standard SOP to standard form and then represent it in the canonical form in this way. So with this we come to the end of this video. You can find me at Facebook, Twitter, Gmail and Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon to get notifications about future videos. Then thanks for watching. Have a nice day.